Hey guys, we're going to do 6.8 graphing radical functions, and we're specifically going to talk about graphing a square root and a cube root function. So I'm first going to start out with square root, and you'll notice here when I'm graphing the square root parent function, I'm not using my typical -2, -1, 0, 1, and 2, and you're going to see why I do that here in just a second. So we're just going to start off talking about the square root parent function. So if I plug in -2 into the equation the square root of x, I would get does not exist. Okay, I cannot take the square root of a negative number, so that makes sense for us to put D and E. If I plug in 0, the square root of 0 is 0. If I plug in 1, the square root of 1 is 1, 2, and 3. So what I'm going to do is I'm going to go ahead and plot those points. And as you can see, this makes a half parabola. Yesterday when I was talking about inverses and we graphed the plus or minus, you would see the other half down here mirroring that positive. But since we just are graphing the square root, we only need that one side. Okay. So again, the reason why I picked numbers that worked out nicely is because I want to be able to take the square root. So that leads me to the domain and range. The domain of a radical has restrictions. In this case, x has to be greater than or equal to 0. In my range, also, y was greater than or equal to 0. And you can see right here, we call this the starting point. And my domain and range are based around that starting point. So on this page, we talk about all of the transformations that you can have to a radical. So just like before when we talked about in Module B and C and D, all of these transformations that we've learned still apply here even with the radical family. So here you'll notice if you have a negative out front, that means you still have that reflection. If you are multiplying by an A value, if that A value is greater than 1, it's a stretch. If it's a fraction between 0 and 1, it's a shrink. We also know that as a compression. Lastly, if you have anything underneath the radical, that's going to be represented by your horizontal transformation. If you have anything added outside or subtracted outside, that is going to be your vertical shift. Okay. So our transformation form altogether would be a times the square root of x minus h and then plus k out to the side. So a quick kind of shortcut to get your starting point is your hk. Kind of like in vertex form, we had that h and k. That's not unfamiliar, except now instead of being our vertex, that's going to be our starting point. So on this problem, we have an equation in front of us. It says, what is the graph of y equals -1/2 the square root of x minus 3 plus 1? The first thing I want to do is I want to label that starting point. My starting point would be 3, 1. So just like if this radical was like parentheses, it's the opposite of what's inside there. Okay? From here, I can make a list of all of my transformations. We have a reflection over the x-axis. Why do we have a reflection? Because of that negative right there. This would be compressed by 1/2. Again, my a value is a fraction between 0 and 1. I would have gone right 3 and up 1. All right. Now this takes us to the domain, okay? Your x values have to be greater than or equal to 3. Another way you can think about this is what's going to make this inside here go to 0. Because I can take the square root of 0. I can't take anything less than the square root of 0. So that's another way to look at it. X has to be greater than or equal to 3. For your range, okay, this one's a little tricky. Your y values are actually going to be less than or equal to positive 1. Why is it less than or equal to? You guessed it, it's because of that negative out front. Okay? So now I'm going to start graphing. I'm going to always start with my HK. So that would be 3, 1. And now I want to ask you all, I need to pick some nice numbers to plug in for X in order for this graph to work. So let's think about that. What are some nice numbers that I could plug in for X in order for this to work out nicely? Well, we started with 3, okay? That started with 3 and it gave us 1. Could I plug in 4? Yeah, I could plug in 4 because 4 minus 3 gives me the square root of 1, which I know is 1, okay? So negative 1/2 times 1 is negative 1/2 plus 1, that gives me a positive 1/2. And I can plot that point, 4, 1/2. Another easy point to plug in here, we would want to plug in 7. Why do I want to plug in 7? Because 7 minus 3 would give me the square root of 4. And we know the square root of 4 is 2. So negative 1/2 times 2, and then plus 1, that gives me negative 1 plus 1, which gives me 0. So I'm going to plot that point as well. 4, 5, 6, 7, 0. As long as we have enough points to see this graph, typically I like to do 3. You could get away with 2, but 3 is definitely more accurate. Now let me emphasize, if you need help figuring out what values to plug in, just remember, you want this under here to go to a number you can take the square root of, okay? If you're having trouble plugging in, use a calculator, okay? You can definitely do that. Again, does my graph make sense with my transformations and my domain and range? Yeah, okay? See from the starting point how it goes down? The reason it goes down is because I have that negative out front. All right, let's go ahead and move on to another one. If you want to pause the video and see if you can try this one on your own, I highly encourage you to. But if you need some more guidance, here we are. We're going to walk you through this again. My starting point is my H and K. So this time it would be negative 2, negative 4. My transformations, I would have a stretch by 3. I would go left 2 and down 4. My domain here would be X has to be greater than or equal to negative 2. Again, what's going to make this inside right here go to 0? That would be a negative 2. Or you can think of it as your H value for your starting point. Same thing for the range, but in this case, Y is going to be greater than or equal to negative 4. Why is it greater than? Because my A value is positive. So I'm going to go ahead and graph my starting point, negative 2, negative 4. And again, let's come up with some values that we can plug in. So we started with negative 2, negative 4. What would be another good value to plug in for X here? The next best one would be negative 1, because if you plug in negative 1, what's going to go underneath that radical? that would become a positive 1. 3 times the square root of 1, that's just 3 times 1, minus 4 gives me negative 1. Another good point, I don't want to use 0. 0 plus 2 gives me 2. I can't take the square root of 2. Another good value would be positive 2. 2 plus 2 gives me 4. The square root of 4 is 2, so 3 times 2 gives me 6 minus 4, that gives me 2. I have all my points, and I can graph. If you have any questions, please feel free to pause the video. Go back and watch me teach this one more time. You can come and ask me any questions as well. All right. For the next part of this video, the cube root, go ahead and select the next video clip, and we'll do cube roots.